So there are two ways to store data in files. We can store data as text in text files, which is what we have done so far, but we can also store data in binary files. Examples of binary files are images, audio files, PDFs, and so on. Now, these binary files, unlike text files, are not human readable because the data gets stored in them exactly the same way it's stored in memory. So these binary files are for machines and not for humans. We often use them when we are dealing with non-textual data, meaning numbers. For example, an image is represented using millions of pixels, and these pixels have numeric values. That's why images are stored in the binary format. So without too much theory, let's jump in and see an example of a binary file in action. So let's create an array of integers and initialize it with three numbers: 1 million, 2 million, and 3 million. Now, before we talk about binary files, let's store these numbers in a text file so we can compare them side by side. So first we create an output file stream. Then we open that file. We can call that numbers.txt. Now we can actually combine these two lines into a single line. So when creating this file object, we can specify the name of the file right here. Okay. Now we check to see if the file is open. Then we're going to iterate over our array and write each number on a new line. So we can say for auto number in numbers, we're going to write the number followed by endall to our file. And finally, we're going to close the file. That was the first step. So let's run this program. Good. Now we have this file, numbers.txt, with three numbers. Beautiful. Now I'm going to show you the size of this file, and I want you to take a note. So now I'm going to open a terminal window and run a special Linux command to show you the size of this file. So this file is 24 bytes. Can you explain why this file is 24 bytes? Pause the video and think about it for a few seconds. Okay, here's the answer. So look, 1 million consists of 1 followed by 6 digits. So here we have 7 digits or 7 characters followed by the new line character that is not visible to us. So on each line we have 8 bytes or 8 characters. That is why the total size of this file is 24 bytes. Now take a note of this. Now we're going to store these numbers in a binary file so we can compare the sizes. So back to our main file. Now we're going to create a new file with the extension of bin, short for binary, or dat for data. We can use any extension we want. Now, as the second argument, we need to pass the mode of this file. And for that, we have to use iOS. That is one of the classes we talked about earlier. :binary. So binary is a field or a constant defined in this class. Okay. So now we're going to open this file in binary mode. Now, instead of iterating over this array and writing each number on a new line, we're going to use a different technique for writing binary data. So I'm going to delete these two lines. Instead, we're going to call file.write. Now, this method has two parameters. The first parameter is a constant character pointer, and this is the address of a part of memory we want to write to the disk. So we want to go in the part of memory where we have stored in this array. We want to grab the bytes allocated to this array and write them to the disk exactly the same way they are stored in memory. But there is a problem. We cannot use the address of numbers here because numbers is an integer pointer. But we need to convert this to a character pointer. That is what this method expects. So to do that, we have to use a special operator. It's called reinterpret_cast. I know the name is a bit confusing, but it is what it is, so we have to deal with it. Now here we type angle brackets and specify the type of pointer, so character pointer. Then in parentheses, we pass the address of our numbers array. So with this expression, we are representing the address of this array as a character pointer. Okay? Now, the second parameter of this method is the number of bytes we want to read from the memory and write to the disk. And for that, we have to use the size of our numbers array. So using this method, we're going to go in the location where we have stored the numbers array. We're going to read all the bytes allocated to this array and write them to the disk. Okay? Now, let's run the program and see what we get. All right, good. So in this folder, now we have a binary file. Look at the content. Now I'm going to open this as a text file so we can see it. Look, we don't see those numbers like 1 million, 2 million, and so on. This is how these numbers are stored in memory. Now here's the interesting part. Let's open up the terminal window one more time and look at the size of these files. So I'm going to look at both number files. Now look, our text file is 24 bytes, but our binary file is 12 bytes. The reason our binary file is 12 bytes is because on this machine, each integer takes 4 bytes of memory. So we can store 3 integers in 12 bytes of memory. So if we're dealing with a lot of numbers, it's more efficient to store these numbers in a binary file, the same way they're stored in memory. All right, that's all about writing to binary files. Next, we're going to talk about reading binary files.